Oh no. Oh, this is heavy. I'm not gonna make my deadline. I wish I could go back in time. I could have avoided this whole mess. Oh, far out. New parts. I've been waiting for these. Sweet. Oh no. Oh no. These parts don't fit. They don't fit. They don't fit right. Ah, this is heavy. But we can fix them, right? Doc, what are you doing here?
We can fix them, Marty, but because your parts are oversized, it's going to be challenging.
What do you mean, Doc?
Well, picture this. If you're sculpting from stone and you take too much away, you can't put that stone back. In this case, the stone is your mold. And if your mold is undersized, your part's going to be oversized.
Right. So what do I do now?
You'll have to remake the area of the mold that you took too much steel away from. This could take 4 to 6 or more weeks and cost way more than you initially budgeted.
Oh, this is heavy, Doc. I'm not gonna make my deadline. Does everyone go through this every time they make a part? I wish I could go back in time before we finalize the design. I could have avoided this whole mess.
What you could have done was design your part and mold to allow for steel-safe changes, which would have made it easier, faster, and cheaper to get that perfect fit that you're looking for.
English, Doc. Steel safe? What does that mean?
Steel-safe refers to designing your mold in a way that allows for easy modification by only machining away steel as opposed to having to remake the mold or trying to add steel back.
Right. And how would that help me?
That process would take a fraction of the time, money, and resources than remaking an entire portion of the mold would take. Designing your parts interface areas on the smaller side puts your mold design in a steel-safe position and ultimately optimizes your development and timeline.
All right. You're the doc, Doc.
Next time, make sure you reach out to a design for manufacturing expert so you can limit manufacturing risks. Remember, if you put your mind to it, you can accomplish anything.